When I simplify this, which takes a couple steps, but I notice that some terms do cancel out. And it's not as many terms as canceled out before, but the negative x squared and the positive x squared and the 6x and the negative x. What I'm left with is 2 times h times x. We still don't know what x is, but we have a trinomial on the top, and each of these terms has an h. So just like before, I can factor out that h, and then they cancel each other, which allows me to then evaluate the limit. When I do evaluate the limit, I just plug in 0 for h. Uh-oh, what's this? And so this h back here disappears, and I'm left with negative 2x plus 6. Now, this is different than before. Before we ended up with a number. But look what this is. If I take the x values I started with, 1 and 2 and 4, and I plug them each into this expression, negative 2 times 1 is negative 2, plus 6 is 4, and sure enough, that was the slope that we got when we solved the limit and plugged in 1 from the very beginning. You can pretty quickly confirm for each of these other values that plugging in this x value into the answer to this limit gives you the slope that we found either by sketching and looking at the graph or by taking the limit at a point. And the other thing you should notice is that actually this is a linear function with a negative 2 slope and an intercept of 6. This linear function is this line right here. Okay, so what are we concluding? Well, the conclusion is that a derivative is a function. And obviously you should be wondering, what function is it? And before we know what function it is, we have to specify that actually when you say the derivative, you're not really being clear enough. If I say, tell me who the best friend is, you would say, wait, Miss MV, that doesn't make any sense. Who's best friend? Just like that, when we say the derivative, we have to say the derivative of, and then tell me what function you're starting with. Once you know the function you're starting with, then you can say, oh, the derivative is this other function. For example, the one we just did, the derivative of negative x squared plus 6x is negative 2x plus 6. They're both functions, and they're functions that are related in this special way that this function's output tells me the slope of this function. That's what a derivative is. Okay, let's do a little practice finding them. And before we do that, there are a couple terms and definitions that you need to have down. The formal definition of a derivative that you need to memorize, that you need to put in cram, is the derivative of f of x is a function whose output at x is the slope of f at x. Remember the meaning? This should go out in the left-hand column. The meaning of f of x is the function you start with. The meaning of this new function is a function whose output is the slope of the original. Now, how do we talk about the new function? My favorite notation is the one that I've used here. It's read f prime of x, which is what's being covered down here by the Prezi logo. So I would say f prime of x equals the limit as h approaches 0 of the difference quotient. Unfortunately, as I've mentioned a couple times in class, calculus was invented by different people at the same time, and they came up with the same ideas, which is pretty awesome, but they used different notations, which is a little bit annoying. All of these at the bottom are different ways of talking about the derivative. When I say f prime of x, I mean the derivative of some function f. I could also just call it f prime. So if I say find f prime for me, I want you to find the derivative function. We could say y prime, as long as you already know what y equals, it should be a function. You can say dy dx. This is the function notation that kind of references slope. We think of it as delta y, delta x, but we just read it dy dx. Or we can say the derivative of y with respect to x. That's kind of the formal way, but that's useful when you're explaining your thinking. Similarly, we could say df dx, or the derivative of f with respect to x. We could say d dx of f of x, which is really just saying the derivative of f at x. Make sure that you pause the video and write all of these down. They will come up. I'm not going to warn you when I switch notations. The book certainly won't, and the AP exam won't either. Cool. Now that you have the notation down, let's do some practice. You've just got 3 functions here. Your job is to find the derivative. Remember, finding the derivative means you're going to find a new function. How are you going to find it? Go back and look at the definition. Your work should look a lot like the work that I did at the beginning of the video. If you haven't already, make sure that you've solved A. And here's the work that I completed. Notice that I used a conjugate, and notice that when I use the conjugate, the sign changes in between the 2 terms, the 2 radicals of the terms, but the sign inside the first radical doesn't change. Think about the definition of a conjugate. Coming all the way down, you can see where h cancels, and this is what I'm left with. It's a function. This is the derivative function of the square root of x function. Remember that f prime is how you read the derivative notation right there. If there's something here that confuses you, make sure that you write down the work exactly like I have it, and then draw an arrow to the step that confuses you, and come see me about it tomorrow. That's your job. Let me show you number 2 next. In a way, it's kind of a similar process, but for this one, the algebra worked out differently. Notice that I foiled 2 binomials first, and then I foiled the last one. I also could have combined like terms before doing any canceling. I chose not to. I didn't combine like terms until the last step, but the order of combining doesn't matter. You should end up with 3x squared as your derivative either way. Here's the last one. Relatively short compared to the cubic. This derivative of 1 over x is 1 over x squared. Make sure that you know where the negative comes from. Make sure that you didn't make the mistake of having a positive h on top. That's a super common mistake. It comes from this step where the negative belongs to both the x and the h. That'll be it for today. See you in class.